Hi everyone. In this video we're going to talk about section 6.1 from your textbook, Similarity and Polygons. Today we'll take a look at the first part of section 6.1 and we'll discuss what it means for two polygons to be similar, how to determine if two polygons are similar, and how to find something called the scale factor between two polygons. Take a moment to draw on your paper two shapes that have the same shape but different sizes. So what that means is maybe you want to draw two trapezoids that are the same kind of form, but one's bigger than the other. And want you to respond with something you notice. So you might have drawn something that looks kind of like this. You have a here I drew two triangles that one's bigger than the other. And hopefully something you notice is what gives them kind of the same shape, but a different size. Part of it is that all of their angles end up being the same. So if you look, all of these corresponding angles in that small triangle are the same as the corresponding angles in the bigger triangle. Their sides are what are different. This is part of what makes two figures similar, that their corresponding angles are congruent. So informally, similar figures are two shapes that are the same shape but different sizes. Formally, there's two components of what makes two figures similar, and part of that is all of their corresponding angles are congruent. You might remember from chapter 4 how we wrote congruence statements between two congruent figures. And the way we did that was to make sure that all of their corresponding parts lined up so that the figures were written in the same order. In order to write similarity statements, we more or less do the same thing. So we pick an order for the first shape. So I'm going to call that first shape A, B, D, C. And I want to make sure that second shape goes in the exact same order. So angle A is congruent to angle F. So since A came first in the first shape, F has got to come first in the second shape. And then we go in the same order. So the only difference is the symbol. The congruent symbol is a squiggle with an equal sign. The similar symbol is just a tilde. That's just the squiggle. So that's the symbol for similar. I want you to think back to something you might have learned in middle school that's going to help us talk about this next piece of similar figures called a proportion. A proportion is two ratios that are equivalent. You see proportions a lot in baking. If I need 1 cup of flour for 4 servings, we might figure out, well, how much do I need for 6 servings? And let's call that x. And the way you would solve for a missing piece of a proportion is you would cross multiply. So I would get 4 times x equals 6. I would divide both sides by 4. And I would get x equals 6/4. But 6/4, of course, can be simplified to 3/2. So proportion is two ratios that are equivalent. So 1/2 equals 4/8. That's a proportion. And this is going to help us as we move into our next piece of what it means for two figures to be similar. These two triangles are similar. What do you notice about the ratios of their corresponding sides? So let's look at each pair of corresponding sides. Segment AB, that corresponds, segment AB corresponds to segment DE. So segment AB divided by segment DE, if I look at that ratio, that's 2 to 4. That's 1/2. Okay. Let's look at another pair of corresponding sides. Let's look at side AC. Side AC corresponds to side DF. So the length of AC over DF is, and you might have guessed it, also 1/2. And for our last kind of pair, looking at side BC and side EF, if I take the ratio of those sides, I also get 1/2. So not only do similar figures have congruent corresponding angles, they have proportionate corresponding sides. This is our second piece of what it means for two polygons to be similar. Their sides are proportionate. That means if I take the ratio of any given pair of corresponding sides, I'm always going to get the same value. So in this case, no matter what, if I take any particular pair of corresponding sides and I take the ratio, I always get, in this case, 1/2. It doesn't always have to be 1/2. It could be any value, but the point is the ratio between all the pairs of corresponding sides is always going to be the same. So this brings us to our formal definition of what it means for two figures to be similar. We need both things to be true. Corresponding angles are, this should say congruent. Corresponding angles are congruent, and corresponding sides are proportionate. So again, the corresponding angles are congruent, not proportionate, because we can't have proportionate angles. Corresponding angles are congruent, and corresponding sides are proportionate. This goes in your toolbox as the definition of similar figures. So let's take a look at these two triangles, and let's see if we can determine if these two triangles are similar. We can already see that all of their corresponding angles are congruent. So what we need to do then is look at the ratio of each pair of corresponding sides. So let's start with side AC, which corresponds to side DF. And let's look at that ratio. The ratio of side AC to DF equals 5/4. Right? Let's look at another pair of corresponding sides. Let's look at side AB. Side AB corresponds to side DC. So if I'm looking at the ratio of side AB to side DE, that gives me 3:1. Now 3:1 is not the same as 5:4. That means these sides are not proportionate, so these triangles are not similar. I want to make a note though. It's important that whatever direction you choose to go, you're consistent between all of the proportions. So for this first ratio, I went from the big triangle to the small triangle. It's important you continue that way. So for my second ratio, I also went for the side of the big triangle divided by the side of the small triangle. You got to make sure you're consistent because otherwise you can't compare the proportions. There is a name for that ratio that is the same among all corresponding sides of similar figures, and that is called the scale factor. So the scale factor is the ratio of each pair of corresponding sides for similar figures. You can talk about a scale factor in two directions. You can talk about it from shape 1 to shape 2 or shape 2 to shape 1. So for example, if you were asked to produce the scale factor here, you could have two answers. You could have from the small shape to the large shape. And the way that would work is you take a side on the small shape, take a side on the big shape that corresponds to it, and look at that ratio. Small to large means that small number is going to go on top. So AB is 1, FG is 2, and 1/2 is already in simplest form. So the scale factor of the small shape to the large shape would be 1/2. You could also go the other direction. You could be asked to go from the large shape to the small shape. That would be 2 to 1. We take a side from the bigger shape, FG, divided by the corresponding side in the smaller shape. Usually you will be asked a certain direction, but if you're not, there are actually two correct answers for the scale factor. And I chose to do segment AB and segment FG, but it doesn't matter. You could pick any pair of corresponding sides. That's the whole point with scale factor. You're always going to get the same ratio no matter what. So it doesn't matter which pair of sides you choose as long as they are the pairs that corresponds to each other. So for this question, are these two figures similar? If so, find the scale factor of FHJG to ZWXY. We can already see their corresponding angles are congruent, so that's the first part. Now we need to look at the pairs of corresponding sides and see if they're proportionate. So let's look at each pair together. Let's start with side FJ. Side FJ corresponds to side ZW. So if I look at the ratio of FJ, oops, sorry, used the wrong color. Look at side FJ to side ZW, that gives me 16 to 20. And I want to write my fractions in simplest form, so I find the greatest common factor, which in this case is 4. Oops. And so that ratio becomes 4/5. So that means if these two figures are similar, all of the other pairs of corresponding figures need to be 4/5. So let's look at a next pair. Let's look at JH and WX. And I went from small to big the first time, so that means I have to go from small to big continuing. So side JH over side WX, that gives us 12 to 15. Divide both by 3, that's the greatest common factor between 12 and 15. And that also gives me 4/5. So far so good. Let's look at our next pair of corresponding sides. Let's do YX and GH. I went small to big for the first two, so I got to continue going small to big. GH is from the small shape, YX is from the big shape. That ratio gives us 24 to 30. The greatest common factor between 24 and 30 is 6. So dividing both by 6 gives us 4/5 again. All right, so we're 3 for 4. We just got to check out that last one. So let's look at side FG to side ZY. And the greatest common factor between 20 and 25 is 5. So that gives me 4/5. So I got the same ratio each time, which means yes, these sides are proportionate. So yes, the figures are similar. We have similar figures. The next part asked for the scale factor, and it asked for FHJG, which is the smaller shape, to the bigger shape, ZWXY. We've actually already done that. That scale factor is that ratio we've talked about for all 4 pairs of corresponding sides, 4 to 5. If we had been asked to find the scale factor of ZWXY to FHJG, then the answer would have been 5/4. But this is asking for the small shape to the big shape, so that's why our answer is 4/5. All right, and our last problem. These two triangles are similar. We want to find x. The way to do these kinds of problems is to first identify the scale factor. To do that, we just need to look at a pair of corresponding sides. So corresponding sides, this 12 and this 16 correspond to each other. So let's go from small to big. So the scale factor is going to be 12 over 16, which simplifies to 3/4. Now, each pair of corresponding sides, their ratio has to equal the scale factor. So what that means is if I have x, whatever x is, divided by 20, that's got to equal 3/4. So I can, sorry about that, set up the proportion. 3/4 has to equal whatever x is divided by 20, because again, figures are only similar if their sides are proportionate. So to solve this, I'm going to cross multiply. I multiply each fraction's numerator by the opposite one's denominator. 3 times 20 is 60. 4 times x is 4x. And then to solve for x, we just divide both sides by 4. So x has to be 15. And we can check our work. Does 15 divided by 20 give us the scale factor of 3/4? Yes, it does. So this brings us to the end of the first part of section 6.1.